Now, we talked already about the idea that our probability that we want depends on all our outcomes being equally likely to occur. So, as I said, drawing cards from normal packs, throwing an unweighted coin, tossing a fair die, drawing a ball and lotto. So everything's got an equally likely outcome. But what if we get bias there? So what if something isn't an equally likely outcome? Well, what we need to do then is account for that in our sample space. Now, we don't get these ones too often. But when we do, we have to just account for that in our sample space. So we've got a coins weighted, so it's twice as likely to show a head as a tail. So what we can do is say, well, in any toss then, it's twice as likely to show a head than a tail. Then we can consider a head-tails type situation as our sample space instead of just, oh, it's going to come up a head or tail. Because it's twice the chance of a head than it is for a tail. Which basically we could really treat it as an idea we've got three items in our sample space, and the probability of getting a head would be 2/3 because there's two out of the three. So that would be our probability of a head. So when we're looking at tossing a coin twice, what's the probability of two heads? Well, with a head, probably a head and a probability of head would give us 4/9. Or if it's a tail, well, the probability of a tail then would be 1/3, because we're using ideas of complementary events. So we get a head and a tail, or a tail and a head, 2/3 times 1/3, or 1/3 times 2/3. And that would give us 4/9. And the probability of two tails would be 1/3 times 1/3, which is 1/9. So there's only one chance in 9 of getting that. And notice that covers all the options. So 4/9 and 4/9 and 1/9 gives us 1 in total. So that means, yes, that we've done that correctly, and we've counted for all our items in our sample space. So just be wary. If we've got a bias there, we've got to account for that in our sample space, so we make sure we get all the events that can occur.